Hello folks, LiveOps is a hands-on cloud reliability learning platform. Build.Break.Fix is the lesson flow. An AI agent builds real AWS infrastructure, breaks it safely, diagnoses the failure, restores it while you watch. So let's pick something to learn. I'll be picking up the load balancing. The idea is to show in a real system why one failed server should not take the whole application down. So let's start building. Starting the lesson creates a fresh sandbox session. The learner follows the same incident loop used in real operation. Build the system, inspect it, create a failure, diagnose it, and verify the recovery. So let's build the system. Build Studio provisions real AWS infrastructure, 3 EC2 targets, our target group, an application load balancer, and its listeners. As you can see, the command feed is the actual event stream from the backend as AWS SDK operations run. I'm speeding up the health check. Wait, because the real cloud provisioning takes time, but it is a real run, not a simulation. Once all 3 targets are live, the system are healthy, so the system is healthy. So I'll cut to the part where all systems are healthy. As you can see, the all targets are healthy and receiving traffic. You now have a fault tolerant here. 3 servers behind one load balancer, each continuously health checked. So let's go to the Explorer part. Here you can read the current state from AWS. The diagram is created from real source IDs, as you can see perfectly. Yeah, only see 2 targets. So, and health information not from a static mockup. I can inspect each resource, and this live endpoint is the actual load balancer. So now let's go to the break part. Yeah, so I'll inject the failure. Next, LiveOps deliberately injects one safe failure. The agent deregisters a healthy EC2, as you can see. Yeah, it's happening live. So the load balancer stops routing to it. This represents a kind of failure. After a server crash or bad deployment, one target is out, but the application stays available through the other 2. Yeah. So let's go to the diagnose part and diagnose the failure. Diagnose console asks AWS for the real target health data using describe target health. GPT 5.6 reads that live telemetry and explains which target is affected, the AWS reasons code, why it happened, and the targeted recovery action. GPT 5.6 is reasoning over all infrastructure state, while the agent stays restricted to verify allow listed operation for safety. So let's go to the fix part. As you can see all the reasoning and stuff. Let's go to the fix part. Fix and recovery registers the target. Let's fix it and waits for AWS health checks to verify recovery. The target is waiting for to be healthy again. Yeah, it's healthy again. That all 3 servers are back in rotation and the incident lifecycle is complete. Build, break, diagnose, and fix and verify. And the celebration was there. So let's tear down whole process. Yeah, LiveOps uses real infrastructure, so cost and safety are built into the product. Session are sandbox, rate limited, time limited, capped for concurrency, and can be turned down manually. This removes the session's AWS resources instead of leaving anything running. I used Codex as my engineering collaborator to build LiveOps. It helped me design the review the backend session, state machine, real-time event pipeline, AWS lifecycle, cleanup controls, front-end, backend contracts, test and replay fallback. I made the final product, infrastructure and safety decision. So thank you. Have a nice day.